System Design Netflix. Hi guys, my name is Manish Kumar, and in today's session we will create system design of Netflix. Netflix is a video streaming service where user can watch their favorite movies, documentaries or series on any of their favorite device. The biggest challenge in today's session will be to handle these large size files such that user can watch them without any buffering. So let's start the session guys and see you in the session. Hi friends. Today we will create system design of Netflix. So as you know now, the step one is like to understand the functional requirement of system. So without wasting time, let's collect the functional requirements. So functional requirement. So Netflix. So Netflix, if you see, there are two type of users. One user is like the production houses, like who upload the videos. So user should be able to upload videos, and the second user is user can watch videos, the consumers, and third requirement is feed building. So if I watch some video, it's good for me to see my feed. So based on my preferences, my history, there should be my feed, and I can it's easy for me to choose the video from my feed. Or this system has a big responsibility to build the feed. What else we can cover? Definitely it has to be device agnostic. I want to watch it on my phone or on my desktop or in my TV. So laptop, like it has to be device agnostic. And out of scope is interaction with videos, like commenting, liking is out of scope. And some other things like is criteria, if this is like the user is, if you can create profile like multi-profile and all those things, because in this video we are not going to talk about them. So our major focus will be on these functional requirements, that user should be able to watch videos, they should be able to upload videos, and the feed should be provided for the users, and the device should be, or the system should be device agnostic. Okay, so let's move to next step without wasting time. And the next step is non-functional requirement, NFRs. So in terms of NFRs, it has to be definitely highly available system. System should not be down. In fact, if I'm watching a movie as a user, I don't want to like my system is down after half of it, and or like I have a throwing party tonight, invited friends, and like, hey, we have a movie night, and at the end like system is down. So it has to be highly available, scalable for sure, because here we are dealing huge data gonna grown up, user base will be keep growing. If a new movie launched or something, million of users are like jumping into that right away, or it might have to little bit drop also at some point. So this has to be scalable for sure. And then eventual consistency, and then the latency, we already talked about that. It should be low latency, like not a lot buffering time should be for user. It should give a feeling something like this is stored locally in my system and I'm watching the video from there. I can't imagine if buffering will come in the movie or video, I will keep watching it. Like definitely I will just turn it off, like this is not working. So yes, latency gonna be like, we need the low latency, definitely no buffering at least. So I think we have pretty good on NFR side also now. So let's move to next step, where we actually try to understand what will be the capacity of the system, and we call it like capacity math, which, as I say, like this is some people call it back of an envelope estimates. So let's say 100 million users daily uploading, or maybe 10 million users uploading one video, and average size of video is 100 MB. So this is daily upload video. So if we math it around a little bit, it turned out to be 10 million, 10 into 10 raised to power 6 into 100 MB, which is somewhere 1 GB, 10 raised to power 3 is 1 GB, 10 raised to power 6 is 1 TB, and then 10 raised to power 9 is 1 PB. So 1 PB data per day. That's what we are dealing here. And if we see how much per second data gonna be, so if 1 PB divided by 10 raised to power 5, and as I do here like 10 raised to power 5, I call it like to simplify when I calculate how many number of seconds in a day, which is 24 into 60 into 60, and this is somewhere come out at approx 80k. So I just round it to 10 raised to power 5 to simplify the calculation here in the video and save some time. So but you can do like more granular if needed, but this will give us a high level idea how much data gonna flow over network and what kind of tools and technology we need to use to optimize it. So 10 raised to power 5 is equal to, it is coming around 10 GB per second data. And then we have the download daily watch videos. In this application, the watching will be much more. If 10 million videos, so I will say 100 million people gonna watch at least one video daily, and which is 100 MB size. So this is going to be 10 petabyte of data per day, and 100 GB per second will be the data. So this is like, so this is heavy read operations. So we definitely need multiple read replicas. As you can see, it's a heavy read application. So we need multiple read replicas when we configure the DVs, the databases. And so I think we have pretty good idea here now. As you can see, these videos gonna be stored somewhere. These are just a file storage kind of thing. So either we can store them in a file system, but in file systems there will lot of engineering cost, to achieve, to do like replicas and to make them highly available. This may be engineering cost, but it's totally up to your individual choice what we can do. We can achieve it in file system also, but my recommended way will be S3, which is a blob storage. Benefit here is like I get scalability, availability, and integration with latest technologies, easy integration with latest technologies like CDN, etc. And that will definitely be needed in this case. So S3 going to be our video storage. In addition to that, there will be metadata also. Metadata will be storing like user details. User details as like ID, name, address, contact, email, and type. Is it like production house, like uploading videos, or the consumers, or subscription type, and payment method details. All those things like related to users gonna be here. And then there will be the video metadata like ID and user uploaded it, so user who uploaded this, then tags and title and category and time stamp and and costing related information like which subscription this is this lies in and all kind of thing. And we may want to store something like, number of watches. So this is like, a video. I think we have pretty good knowledge on the capacity. Or from metadata, I can see like this is like relational DB. This user has uploaded this video and all those kind of things. So I will say like some relational DB is like a SQL database. And again, like, SQL, I'm like, because I'm an expert in SQL, I used a lot. So I will little bit biased to that, but all we need a relational database. So we can use other options also, but I'll go with SQL DB here. So now let's little bit talk about the APIs. What are different APIs we gonna use in this? So one for post to upload video. This will be the ID, title, short name, and thumbnail, content. Then there will be get watch video, where user will send user ID and the video ID to watch. And then there will be get feed. The get user will say my user ID is this, give me my feed. These will be, I think, the key APIs we're gonna do. So now the design. So here is, let's say, production house. Here is our service, upload video service. Production house will call the upload video service to upload the video. Upload video service key responsibility will be to store video metadata and send URL to upload video to user. Here it will like be a DB, and as we talked about that, this is SQL DB, storing user, having user information and the videos, and then it will make an entry to this, and here will be the videos, and user will upload the video to drive. And then once the video is uploaded, they'll inform the upload service the video is uploaded, and the corresponding information will be updated here that this video is available now for use. So this is kind of like a flow where video will be uploaded. And before going into download, I'll say like this is not gonna be straightforward upload here, because as you know that we said it has to be device agnostics. So for to being device agnostic, we need something here, and that will be like if the video uploaded, then it has to be transcoded into different format, different quality, by which if your user is like watching video with low network bandwidth, we can send like some low pixel. I'll say here this will be somewhere on the temporary storage, and the user will upload the video here, and then here will be a queue, and this here will be queues, and queues will be kind of like for each video, like this has to be, think it in something like this. Transcoding service, which is kind of workers working on this queue. I'll say transcoding service, and this transcoding service job will be, let me drag it a little bit down here, and this transcoding job will be, and this is not 780, sorry, 720, and then 10, 80, and then if I add one more row here, it's something like 4K. I'm just taking some example here, and then AVI format, or and something like MP4. So basically what transcoding service is doing, it's like having a worker is like picking the information here and saying like, okay, I'm just picking this, that I'm converting this into 4K and AVI format, and that in that format this gonna upload the data into S3 like something, and then it will mark it done. So this is kind of done. Now the one problem I can see here, because these videos could be like heavy, user will not be sitting there continuously to get upload the video over there, and or keep the system on and do all those things. I think what user need to do here, the chunking service. So basically what user client side service app is doing, this is like on the client side, the end user end. So what that is doing, when user is giving a video to the service to upload, the chunking service on the client side is actually breaking the video into small chunks. And those chunks, like if there, and that chunk independently a small, just like a small video, like if it is 1 hour video, maybe like I'm just taking an example in terms of time. If it is 1 hour video, each 1 minute, 2 minute video is like a chunk. And that particular like a small interval of time video is like independently uploaded like into temporary and independently saved into S3. From transcoding service point of view, from storage point of view, this is independently a file which gets stored here in the S3. So the benefit of this is, if I have a big video uploading and I just uploaded it, let's say for half hour, and after that my system got turned off or something happened, that's okay. The video, the chunk part, the uploaded up to within that half hour is already done. Here, the production house has a video ready and they want to upload it. So they use the client app. They say like, okay, we want to upload. And we are not talking more about the client app. Just think like client app is there where like they can provide a URL and input all the data required for the video. And then they reach out to the upload video service. And now upload video service will store the video metadata here and send a URL to upload the video for the client app. Then client app is chunking, like breaking the video into chunks, put an upload temporary storage, where we have workers, transcoding service, taking out the videos from the queue, and each worker is picking a particular chunk of video to transcode into a particular format and upload it to S3. Then like another worker takes to another thing, and then they do this exercise for the entire video. Once all the chunks related to that video are uploaded here, means video is uploaded, transcoding service going to inform the upload video service that video is ready. And now the production house is alerted or informed that video ready. So far the video is uploaded. Now the second thing comes here is the consumer. So if I go here, I say the watcher, I'm calling it. I'll say watch video service by sending a request that this particular ID of the video I want to watch. Then watch video service check the metadata and information in this and get the URL of the video from where they can use it, and then allow watcher to download the video and start watching it. Now the question comes here, video should not have the buffering as we talked in our non-functional requirement. It should be low latency. If the video will be uploaded from S3, so watch video will see the detail of device, what device user is using, and based upon the network bandwidth and all the data, it will choose a particular format which is good and most suitable for the watcher. But still, like downloading the video from S3 will not be helpful. So what it will do is like it will have the video here This will be a CDN. So what it will do is user will download the video from the CDN, and if video is not in the CDN, it will be downloaded from S3. So now user can watch video through CDN. So user is happy, he's getting no buffering, right format of the video coming to that, and he's good with it. If the video is not CDN, it has download from S3. And again, keep in mind the video is broken in the chunks. So every time chunks are coming. So when user is watching the first chunk, the second, third, fourth chunks are like in the queue getting downloaded. So if you notice sometime if you scroll to more like into the forward, so it will have some buffering because that chunk is not yet downloaded over there. That's how it works. So the downloading is continuously happening chunk by chunk, by which by the time user finish a chunk, the next chunk is ready to watch and no buffering. He's good with it. So far, like user can watch the video and the format and everything. This is the watch video. Now the most important part, which is gonna be interesting, is the feed builder. Let's see how that will work. So we have feed builder. Sorry about that. So what will be the key responsibility here? We see the feed builder. Feed builder will create or like build a feed based upon user watch history, which means it needs some kind of access to log information, history log information, user preferences, and those user preferences will be stored in the metadata for each user. So based upon this information, feed builder will build the feed for the user. And how will that work? So for the history information, we need a database to store history. And when we talk about, logging and all kind of things, the most suitable database I can think of is like Cassandra. When user will watch a video, it will make an entry in the user history here that this particular user watched this particular video. And the feed builder will get this information from Cassandra, and then user preference will be fetched from the metadata. Now this feed builder know what is user preference, what are the history user has watched, and based upon this information, it will check for the available videos for the user and will provide a feed for the watcher. Now the question is, because this feed builder is something, because feed should come right away, no, like super low latency. If I'm logging in, my feed should be there. So feed builder should have the feed already like kind of ready to show. So feed builder is a backend service which is continuously making like feeds for user. So maybe I'll say like it's storing here in a Redis cache. This is a persistent cache. We know like Redis. We can use memcache also here. Memcache is not persistent. So if that due to some reason, if it goes down, then we have to build the entire feed again. So yeah, Redis will give us better option. So I'll go with the Redis here. So user can store, the feed builder will store the feed in the Redis cache for each user. Whenever the user will get logged in, he will get his feed. Now how the feed is getting updated is the question. So when a video will be uploaded here, that video will have a particular meta tag, and if the meta tag that particular video, so how it will look like, it's gonna be interesting. Let me make little space because I have to put a queue here, and it could be any like a processing queue, it could be a Kafka or something. So I will use Kafka here. So a video will be uploaded and that entry will go into Kafka, that yes, this video is uploaded here. Now there are the workers who are working at the top of this Kafka to build the feed, and these workers are continuously working, I'll say, through this Kafka. And okay, this video is uploaded, so they are uploading and the providing information to the feed builder, and feed builder is now putting information into Redis cache. So new video is coming, and that lies in my preferences. So the Kafka, it will come, the worker will go, oh, this video is good for Manish. So let's put it in his feed. And that feed will be continuously keep updating, and I will have my feed always ready here. But there is a very interesting scenario I can think of now. And that is, if a video is uploaded for a particular, like for example, something got uploaded for Justin Bieber or something, like who is very, very popular, a million of followers has like want to see that video. So if that kind of video will be here, then it will be a huge workload on the feed builder to keep that like 1 million of feeds updated for that video. So for those kind of cases, what I will suggest, that we will have a fan out service here. And what it will do, it will get the information of the particular video from the DB. And when the user will be logged in and the watcher will come and say, give me my feed, it will have the feed ready. And at the same time, it will check with the feed build fan out service. Is there anything to add into this from like, fan out service? Is there any most popular video came up recently? And the upload video is also informing the feed build fan out service here. So now my feed was there, but because the most popular video came out here, and I'm following that particular actor and I want to see or watch that particular video, that should be part of my feed. So the feed builder at the last time when I'm logging in, taking my feed, asking fan out this is right, and providing the bundle to me. And now I have my feed ready. So let's run the functional requirement again. So upload video, we talked about upload video. We handle the device agnostics here, and the watch video we handled. We have the login DB here. This is like something which we missed initially when we were talking about capacity math here. But that is something I still want to mention, just so this is documented well. For logging DB, we choose Cassandra, and it provides a lot of like inbuilt logging and the cluster. So it's more reliable. So the popular thing is like it's cluster, you get it right away. So that is something which is kind of like I'm leaning towards Cassandra, but if you want, we can use others also. That's perfectly fine. So now the question comes here is highly available. Highly available is like if a service is down, the user should not be impacted due to that. There will be a load balancer and gateway service. So all the users will talk to gateway service only, not directly to any microservice. There will be a session service which will maintain the session here. So this is session DB and gateway. So basically what is happening, that user session is stored at gateway level. So watch video, all the in other microservices, they are not worrying for the session. So they are like stateless services, and they can easily or horizontally scalable kind of thing. So if you see, sorry about that, if I a little bit small it down to save some space, I'll say this is what it's gonna be. So the user production house or the watcher, no matter what user will never reach out to any service. Gateway job is to handle to auth, session, and redirect, and rate limiter also. If those kind of things are happening here, or if we want to put certain content filter, so all those things are happening here. And now the system is highly available, and we have the load balancer, which is kind of like helping to balance the load across different microservices. AWS provide like app load balancer, network load balancer. Network load balancer is pretty good and like can handle million of requests. So we can pick the suitable one. For in this case, I think the app load balancer may be good enough, and we can set the rules. System is scalable. Yes, we have horizontally scalable system. Our S3 database and Cassandra, SQL, all are like good enough. And consistency, eventual consistency, we talked about that. Once the video is uploaded, it's there, and now whatever format, whatever device user is using, the video is there for him to see. So this is definitely a consistent. And low latency is like we have CDN here, We have different formatting to support different kind of network speed, different kind of formats. So this is definitely gonna be low latency. So we talked about that, we handle it. I think we did a good job, guys. So thank you so much, guys, to watch the video, to be with me. If you need something to get down into more detail or a particular topic where I should create system design, please feel free to note down in the comments. Thank you so much, guys.